We are given the parametric equations of a curve. X is ln 2 plus 3t, and y is t over 2 plus 3t. We need to show that the gradient of the curve is always positive. The gradient of the curve is given by dy dx. So we need to find dy dx first. In order to find dy dx, we must find dx dt. Dx dt, since x is ln of 2 plus 3t, when we differentiate this with respect to t, we have 1 over 2 plus 3t. We still need to differentiate the inner function with respect to t, and that will give us a value of 3. Dx dt is 3 over 2 plus 3t. Then we find dy dt. To find dy dt, we can use the quotient rule. So we have 2 plus 3t, and when we differentiate t, we have a 1 minus t. When we differentiate 2 plus 3t with respect to t, we get t. All this is over the square of the denominator, which is 2 plus 3t. In the numerator, we have 2 plus 3t minus 3t. Dy dt is now 2 over 2 plus 3t squared. Dy dx, that is always given by dy dt over dx dt. Dy dt is 2 over 2 plus 3t squared, and this is divided by 3 over 2 plus 3t. So when we are dividing fraction, we have 2 over 2 plus 3t squared. This is multiplied by the reciprocal of the denominator, which is 2 plus 3t over 3. 2 plus 3t, this is common, so we can cancel this. Then we have dy dx equals 2 over 3 times 2 plus 3t. Now, to show that this is always positive, we need to look at the equation of the curve again. Look at the domain for the equation of the curve. Now you see that x is ln of 2 plus 3t. X is only defined when ln of 2 plus 3t is defined. Ln of 2 plus 3t is only defined when the argument 2 plus 3t must be greater than 0. So the curve must be defined for 2 plus 3t greater than 0. When this is greater than 0, x, which is ln of 2 plus 3t, is defined. Then we can say that 2 plus 3t must be positive. Since 2 plus 3t is positive, then dy dx, which is 2 over 3, these two are positive. And if 2 plus 3t is positive, then dy dx is always positive. Part B, we need to find the equation of the tangent to the curve at the point where it intersects the y-axis. On the y-axis, x is always 0. So we need to find the value of t when this occurs. When x is 0, we say that ln of 2 plus 3t is 0. This is only possible when 2 plus 3t is 1. We know that ln 1 is 0. Solving for t, we have 3t equals -1, and t equals -1 over 3. Now the key to making your calculation simple is actually this part here. So when t is minus 1 over 3, x is 0, we need to find the y coordinates. So y here is given by t over 2 plus 3t. From this part, we know that the denominator is 1. So let's look at the numerator. Numerator is just t, and t is negative 1 over 3. Then the equation or the tangent line passes through the points with coordinates 0 and negative 1 over 3. We need to find the slope as well. dy dx. This is 2 over 3, 2 plus 3t. But we know that this is 1. So that dy dx is 2 over 3. Now we have the slope and a point. Then the equation of the tangent is y minus negative 1 over 3. This is dy dx 2 over 3, x minus 0. We have y plus 1 over 3 equals 2 over 3x. Yeah, this is ugly. So let's multiply throughout by 3. We have 3y plus 1 equals 2x. Or we can say that 2x minus 3y minus 1 equals 0. That will give us the equation of the tangent.